All right, we're looking at R2. Here with R2, the goal is going to be to add and subtract rational expressions. All right, so the goal is to add and subtract rational expressions. Now remember, whenever Mr. Stevens thinks rational, you need to think fractional. All right, it's a made-up Stevens word. You cannot use that on the streets. People are going to look at you silly. I've tried it, and people look at me silly. All right, so when it comes to adding and subtracting rational fractions, right? So think back to 4th, 5th, 6th, 7th grade. When you add and subtract fractions, what was the one thing you had to have? Well, one thing you have to have when you add and subtract, you must need an LCD, right? Remember this, lowest common denominator. For example, if I did 2/3 plus 3/4, well, my common denominator between 3 and 4 is going to be 12. So I have something over 12 plus something over 12. What did I multiply 3 by to get to 12? It was 3 by 4, so I need to multiply both the top and the bottom by 4. 4 times 2 is 8. What did I do to 4 to get to 12? I multiplied by 3, and 3 times 3 is 9. And then 8 plus 9, we know, is 17 over 12. Right? So it's the same thing when it comes to adding and subtracting rational expressions. The same thing applies. I have to have an LCD. So let's go through a few examples. We're going to go through a few examples, and I want you to see what happens as we do these. A lot of them are going to be just like this, where I take the original denominators and simply multiply them by each other. So the first example we're going to take a look at, we have x plus y over 18xy minus 6x plus y over 18xy. All right. So notice what happened over here. I had my common denominator. Although I left it as two fractions, my second step was to get a common denominator, right? Well, here I have a common denominator. My denominator is 18xy, 18xy, so I can go ahead and subtract these two. But pay attention to what happens on my second step. My second step, I'm going to have one fraction with one denominator. And now I'm going to take the first numerator, x plus y, minus, and the second one I'm going to make sure I put in parentheses. Since I put this in parentheses, the reason I have to do this is that I need to know that I'm subtracting the 6x and the y. So what ends up happening is I end up with, again, my denominator, 18xy, and now I have x plus y. Now the subtraction, I have to distribute to both, minus 6x minus y. Now I could combine like terms. So I have an x and a negative 6x, and that would give me negative 5x. A positive y and a negative y, that's gone. Y minus y is 0, and it's gone. And then my denominator, again, is 18xy. Finally, once I've subtracted, the last thing I want to do, I want to check to see, is there anything left over for me to simplify? Back from R1, right? Well, here, x divided by x, that's gone. That's a 1, and now I'm left with negative 5 over 18y. And that is my final answer. Now, I want to review these steps, and I want to spell this out a little bit. I want to spell this out. So let's review what happened, and let's I want to make sure that we know these steps one by one, what happened, so that you could go back and review as you go through and do yours. So first things first, step one, I need to find a common denominator. And here in parentheses, I'm going to write if needed. Right? Because this one already gave me a common denominator, so I didn't have to. Right? So one is only if I need to. And then step two, I'm going to make it a single fraction where with the original numerators in parentheses. So this is a single fraction, so really this is my step two here. This is a single fraction, and my numerators, I want to make sure I put those in parentheses. And really I could have put the first one in parentheses as well, just to make sure I highlight that. So a single fraction, and the original numerators, these guys here, are always going to be in parentheses. Step three. So when I go from here to here, what did I do? So I'm going to say it like this. If subtraction, if this is addition, I don't need to worry about it. But since it's subtraction, then I need to distribute the negative. Right? I need to distribute this negative. And this is the same as it was whenever we were dealing with polynomials, regular polynomials. All right, step four, I need to combine like terms, right? That's what we did here. Combine like terms in the numerator. Right? So just the top side gets combined like terms. And step five, simplify if you can. So here we had to simplify to get to the final answer. Okay, I have a few more examples. I know I've done a lot with this one example, but I have a few more examples. We're going to do some more addition and subtraction. So let's see what happens as we go on. The next example we want to take a look at . Let's say we have 8 over 7x minus 6 plus 4 over 3x squared. Okay, so again, our first step. Do I have a common denominator here? No, these are not the same denominator. So if they're not the exact same denominator, what I'm going to do is I'm going to say this thing times this thing. So when I go to my second step here, I end up with 7x minus 6 times 3x squared. So this is a whole lot like our original example. So the 3 and the 4, well, what did we do at 3 and 4 to get to 12? Well, we just simply multiplied them together. But pay attention, I'm not going to distribute the 3x squared here. I'm going to leave the denominator in factored form. Okay, I'm going to leave the denominator in factored form. Now, I need to ask myself, what does the first numerator missing? Well, the first numerator is missing this guy. So I have 8 times 3x squared. Plus, now here's my plus sign. And then I have a 4 times this guy. So I'll have 4 times 7x minus 6. Now, I want to break down my parentheses, and now here I'm going to have to multiply and distribute. So we get all over, we have 7x minus 6 is the denominator times 3x squared. All right, that was our denominator. And now I'm going to multiply. 8 times 3x squared is 24x squared. 4 times 7x is a positive 28x, and 4 times negative 6 is a negative 24. And now I'm really asking myself, can I simplify this any? Well, I could probably factor a 4 out. I know I can factor a 4 out of all these, but can I cancel with a 4 in the denominator? No. So at that point, I'm done. And that is it. It's as far as I can take this one. All right, let's do one more example here. I have 2 over x plus 3 minus, okay, we have subtraction, so we need to be careful here, 6x over, and we have a 2x plus 1. All right, so do I have the same denominator? No. So my common denominator is going to be x plus 3 times 2x plus 1. And now I know the numerator on the left side, the original numerator here is a 2, and it's missing the 2x plus 1. So I have 2 times 2x plus 1. The minus sign goes here. And then we have 6x times, and this one was missing the x plus 3, so I need an x plus 3. And now I'm going to distribute. And now this time when I distribute, I have to distribute the negative 6x. So here, 2 times 2x, well here, let's get our denominator in, x plus 3 and 2x plus 1. All right, now when I distribute 2 times 2x, I get 4x. 2 times 1 is a positive 2. And now I got to distribute the negative 6x. So negative 6x times x. I'm going to circle this just so I know, hey, I'm distributing here and here. So negative 6x times x is a negative 6x squared. And negative 6x times 13 is a negative 3 is a negative 18x. Now I need to combine any like terms that I have. So I'm going to go ahead, and for my final answer, my denominator stays the same, x plus 3 times 2x plus 1. And now starting with the largest exponent, here I have a negative 6x squared, so negative 6x squared. So that one's gone. A 4x and a negative 18x is negative 14x. And then a 2. And I could probably factor a 2 out, although I know I can factor a 2 out, but is that going to cancel with anything in my denominator? No. So here I am done.